engine running.
Absolute genius.
Get this.
Welcome.
This is the show where we bring you
Science.
What that essentially means is
discoveries,
Advances.
questions,
Research.
technology.
Unbelievable.
Without further ado,
This is The Naked Scientists. Hello, welcome to The Naked Scientists, the programme that brings you the latest breakthroughs in science, technology and medicine. I'm Chris Smith, and this week your questions are going under our microscope, and we'll be asking our guests to give their expert insights on a number of topics, including why does asparagus make your wee smell, and does it do the same to your breath? Could plastic-eating worms help prevent pollution in future? And what's going to happen to the International Space Station? Plus, there will of course be our customary quiz at half-time, and you can play along too.
The Naked Scientists podcast is powered by ukfast.co.uk.
And with me to tackle your questions this week are Lewis Dartnell, who's an astrobiologist interested in the search for microbial life on Mars and elsewhere. He's also the author of a number of books, including a new one he's just bringing out called Being Human, How Our Biology Shaped World History. What's that all about?
For this new book, I'm looking at all different aspects of us as an animal, as a species, of our humanness. So things like our genetics or our anatomy and our physiology or our psychology and things like cognitive biases, and how they've had a huge influential effect through the course of human history. So how has a particular mutation in Queen Victoria end up indirectly leading to the Russian Revolution 100 years later, for example?
Is that haemophilia?
It is haemophilia, exactly.
Yeah.
A single point mutation that's appeared to have arisen spontaneously when she was fertilised.
And so the point you're making is that because we make the world, things that change us change the world we make.
Yeah, exactly. So humans today living in our glittering skyscrapers are basically the same as our ancestors living 100,000 years ago in Africa. Our humanness is the same, and we have been a constant throughout history. So what I'm doing through the chapter of this book is unpicking the sort of thread of these stories of how different aspects of our biology have had these long-range, long-term effects on the course of history in terms of its themes and its trends or particular events, particular outcomes.
And what's the relation between that and the fact that you're looking for life on Mars?
Oh, very little, to be honest. So my first book, called Life in the Universe, Beginner's Guide, was all about astrobiology and how we're looking for aliens, how we're looking for life on other planets. But as a research field that I research in, astrobiology is very interdisciplinary. It's biology overlapping with planetary science and space science and astronomy and geology. So I've kept that sort of interdisciplinarian hat on through all the books I've written. So Being Human will be my fifth book now, of looking at science and at how it overlaps with other things. So science and history in this particular case.
It's great to have you with us, Lewis. Thanks for popping in. Also here is Ems Lord, who is the director of Enrich. That's Cambridge University's Maths Outreach programme. Now, last time you were here, Ems, and I should just tell everybody at home, GCSE Maths starts tomorrow. And so I brought in a GCSE Maths question. And the reason I brought it in is because my daughter gave it to me and she said, this is a really hard question, can you do it? And I thought, oh, this is easy. And I had to go at it. I thought, no, actually I can't, but I know a woman who can. And because Ems is coming on the programme, and I've given it to Ems and she's been tapping away doing that. So we'll impart and share with the listeners what that question is later on. I don't know if you're making progress, but the last time you were on, and the reason for that long spiel is it was the day that Sunak said, I want to see people studying maths through to 18, and I want to increase mathematical literacy in the general population and numeracy. There's been a bit more detail added to the formula and the equation since then. Your views?
You're right, there has been more background provided, and that's been incredibly important because I think when we all first heard it, everyone was throwing their hands in the air going, how are we going to manage this? Where are we going to get the teachers? How's everyone going to manage to take A-level maths? And I think we've got some really interesting conversations going on. How does that look for apprentices? How does it look like for A-level students? Right now, it's actually a really exciting time to be involved in Maths Ed and be part of those conversations.
Your role in Enrich, is that really an ambassadorial role to kind of explain and show people that maths is not as scary as they might think it is?
I would never think of maths as being scary, and I think
But that's because you're a mathematician. I find it a bit intimidating.
But we're all mathematicians. You're using mathematics every day. You know, people sat on either side of me here in the studio are using maths every day. So
Well, they are at the moment because we gave them the same question. They've got a page of notes as well.
But the thing is, we're all using it. So we're all mathematicians, just like we're all readers and we're all looking at text every day. So I think to get away from this idea that mathematics is just what you do in the classroom and look at it more as something that we do every day, it's a really useful tool and lets us do some fantastic things. Mathematics is part of our everyday lives.
Thanks, Ems. So that's Ems Lord, who's with us. Anna Poshaisky is also here this week. She's been on the programme before, a couple of years ago, I think, wasn't it, Anna? You're a materials scientist. You're very interested in how things are made, what they're made of, and therefore the properties that what they're made of endows them with, and how to give them additional properties.
Exactly right. But the difference, I guess, with what Lewis looks at, he's looking at how biological materials and beings are made. I'm talking very much about kind of human-made stuff.
Well, give us some examples of the kinds of things that float your boat.
So back in my days as a researcher, I was looking at new materials that can store hydrogen. This was with a view to being able to contribute to the vast range of materials that help us to hopefully try and mitigate climate change and create a more sustainable future. So these hydrogen storage materials, which people might be familiar with from the movie The Glass Onion, which came out just before Christmas, these materials store hydrogen, which is normally a gas, a very lightweight gas, as a solid. The benefit of that is that solids are much more dense, and it means that we can carry around a lot more hydrogen with us in a smaller and more lightweight way. The reason that we'd want to do that is that hydrogen contains a lot of available energy. So we can also make hydrogen from plain water. So it represents a really exciting potential new energy source for a really sustainable future if we can crack a few of the material science conundrums.
It sounds like we need breakthroughs like that, because I saw an alarming headline this week that we're predicted to breach the Paris Agreement's 1.5 degree temperature target, but by 2027. I mean, this is just a handful of years away.
It's a very, very, very scary statistic, yeah. And so time really is of the essence for us all to pull together in order to do what we can to help mitigate the damage from climate change.
That's Anna Poshaisky. She's with us. She's a materials scientist. We'll be talking to her about the materials that we use and the materials that we don't yet use or don't even yet know exist that we could put to useful uses out there in the wider world. Also with us, Xander Byrne, who is an astronomer. He's from the Institute of Astronomy at the University of Cambridge. What is it you work on?
So I'm just about to start my PhD, actually. So I'll probably be doing something to do with modelling planets around other stars, perhaps looking at their atmospheres and getting an idea of what they're made of, perhaps with a view as well to assess how habitable these planets might be.
There was a report in the paper this week about a massive explosion that astronomers dubbed the biggest explosion they had ever seen. What was that?
It's called Scary Barbie. Why not?
Who named that?
Well, the
And
acronym
why?
for the way that it was catalogued was ZTF20 ABRBEIE.
Trips off the tongue, doesn't it? It's very
Exactly.
catchy. I can see why they may have wanted to rename it.
Exactly. Astronomers are really, really bad at naming things.
Where did it happen?
It happened in a very, very distant galaxy. There's a bit of a problem in
Needless to say,
astronomy.
a galaxy far, far away.
Exactly,
Yeah.
exactly. Astronomers always have a bit of trouble working out how far away things are, because if you see something bright, it could just be something really, really bright very far away, or it could just be really close by.
So
But
what blew up?
it's not exactly known. There's two sort of major competing theories about what it was. But what it probably was, the best theory that we seem to have at the moment, is that it was a cloud of gas falling onto a supermassive black hole. This would probably be something, I think it was about 100 million times the mass of the sun, the black hole that is, and then the gas fell onto it, heated up, got to incredibly, incredibly high temperatures, burst into this big explosion 100 times the size of the solar system.
And how did they spot this? Are there telescopes scanning the sky for these sudden emergencies of bright lights and things all the time then?
Yeah, it was discovered by a facility called the Zwicky Transit Facility.
Oh, well, that's brilliant. So if you have any space science questions or any questions on maths, any questions on materials science or astrobiology, life on Mars, then now's your chance to have them answered by our dream team. And you can email us. It's chris@thenakedscientist.com. OK, everyone at home, this is to get yourself a maths GCSE, or at least 4 marks. This is how many marks you get for this question. It says the cost of a mobile phone is X pounds. The cost of a television is Y pounds. When both prices are increased by £40, the ratio for the cost of the mobile phone to the cost of the television is 15 to 22. When both prices are decreased by £100, the ratio for the cost of the mobile phone to the cost of the television is 8 to 15. Find the values of X, in other words, the cost of the mobile phone, and Y, the cost of the television. So we'll give you the answer, or Ems will give us the answer, because I'm ashamed to admit I found it made my head spin. The way it's worded is very, very hard, isn't it? Do you think?
I think when you have questions like this and you have to spend so long getting your head around it, it then comes back to, OK, so what's the way that we solve problems? And I think the first thing is trying to put it into your own words is absolutely key, and just having that really good strategy. But even then, because you've got those 2 different parts to it, there's a lot going on. And there's quite a few different strategies you can use. I don't recommend trying to solve the problem at the same time as talking on the radio. I do think that's a little bit of a challenge, but there you go.
Thank you, Ems. Well, in a minute, you can put us all out of our misery. Anna, we've got a question here from Sally, who, this is relevant to what you were saying at the top of the programme and about climate change and so on and environmental quality. Sally is saying, is it true that biodegradable plastics aren't actually that much better for the environment than other plastics that are made in the more traditional way? Has Sally got a point?
Sally, you have touched on one of my favourite topics. Yeah, I think one thing that we have to be really careful about when we talk about materials, but also kind of things that are good and bad for the environment, is this word being better, this kind of value judgment of like how good a material is. It can either be polluting or it can be something that gets into the bellies of sea turtles. But calling it better or good and bad, I think, is a little bit, it's tricky to get our head around, I guess. To talk about the idea of biodegrading, it's important to think about what is it that we want these materials to do. Because I think when we talk about things being better for the environment, ideally what we want is for the stuff that we make and produce and use and then dispose of, for that to have ideally 0 impact on our natural environment. So the holy grail really for materials is that they exist in what we call a circular material economy. In the same way that in the natural world, all the materials that are produced by plants and animals come from other plants and animals and eventually end up going back to plants and animals. And so if we were to think about our ideal situation for what we do with our materials, it would be a very good idea to look at the natural world and how the natural world creates this extremely circular material economy, because our man-made material economy is pretty linear. We dig stuff out the ground, we use it, we throw it away. So to look at the natural world, how does it actually recycle its materials? A lot of the time it biodegrades, which means that little bugs and worms and bacteria and fungi come along and they use those substances, those materials, as food quite often, or a place to live. Our materials that we are making, our synthetic materials, being able to be biodegraded, what we're hoping for are bacteria and worms, etc., that will be able to find the stuff that we make a useful nutrient source.
And is it possible to do that, Anna?
Yeah, it is. It is. In 2016, scientists found that there are types of bacteria that consume the sorts of polymers that we make in a synthetic way. The problem, though, is that the situation, the environment that you need, the conditions that you need for that to happen are often very specific. So when we talk about biodegradable materials, what we're hoping is that the end products are going to be friendly, are going to not harm any animals in the environment. Unfortunately, a lot of biodegradable materials either don't fully biodegrade, so they break down into microplastics, which then wreak even more havoc to the environment, or they degrade into substances that are basically like liquid polymers or liquid plastics, which can even more easily get into our ecosystems and start causing havoc there. So we need to be careful about, if we're just creating biodegradable materials, we need to make sure that the actual products that they are degrading into are going to be okay for the environment still.
That's a very good point, that we can end up in the same way that we're exporting our manufacturing to another country and then saying, look, we've cut our carbon emissions, they're just happening somewhere else. If we're not careful, if we don't look at the full cycle, as you point out, then you could just be robbing Peter to pay Paul, couldn't you? Lewis, this question is from Kirsty. And it's sort of relevant to what you're saying with your book about how everything you see in the world around you is down to us, our biology and our physiology. This is what she says.
Is there an evolutionary benefit of friendship?
Yeah, it's a great question there, Kirsty. So one of the central things that psychologists have been trying to understand about human behaviour is why we're just so good at helping each other out. We're very cooperative, we're very altruistic to each other. And one of the best explanations for why people help each other out, and indeed why animals of the same species help each other out in general, is called reciprocal altruism. So if I help you out, then a bit later you help me out, and we've both, sort of increased our fitness and sort of helped our own survival. The problem with that, though, is you have to run some kind of ledger or log about who has helped you in the past and who's kind of cheated you by taking your help and then not returned the favour later. So you don't want to do too much of that, of trying to remember from all the other people in your community or in your society who's cheated you or who's helped you in the past. So if you develop a particularly close relationship or association with another individual, i.e. you develop a friendship, you no longer really have to bother remembering every time you've helped them or they've helped you. You just come to trust them that they'll return the favour later. And it sort of simplifies that whole behavioural problem.
This does just sound like a way of trying to not have to pay your friends back for things.
So I think you can assume that by the time you've forged this close relationship with someone, which we call in humans friendship, you kind of trust them. And if someone cheats you enough times and doesn't return that favour for the 16th week running,
the friendship breaks down.
They cease to be your friend, right?
Fair enough.
Thanks very much, Lewis. You're listening to The Naked Scientists with me, Chris Smith, and I'm joined this week by a panel of big brain people. With me are astrobiologist Lewis Dartnell, who's looking for life on other planets, including Mars, and he's also written quite a few books about this and other topics. We have mathematician Ems Lord. On the line, material scientist Anna Pashysky is with us, and Zanderburn is an astronomer. Ems, shall we look at this maths question? Because I noticed that the other two have stopped scribbling. You have a page of notes. I'll just remind people what the question was. It was the cost of a mobile phone is X pounds and a television Y pounds. When both prices are increased by 40 quid, the ratio for the cost of the mobile phone to the cost of the television is 15 to 22. When both prices drop by £100, the ratio for the cost of the mobile phone to the cost of the television is 8 to 15. Find the values of X, the mobile phone, and Y, the television. This is a GCSE maths question from last year's paper. What do you make of this question? Do you think this is a good question? And B, how on earth do we do it?
Okay, well, I think the first thing about the question, a good maths question is one you want to solve. And looking at this question, I think my first reaction was, and I don't think I'm the only one in this room who thought the same way, how fast can I get out of here? It's not something that, you wake up and think, oh, that's the sort of question I want to solve when I do my maths. And I think it's really important that we set engaging questions and ones that link to real life.
Well,
and I think there's been an effort.
I was laughing because we've got a brain pan in here the size of a planet. I mean, the IQ of you lot combined is into hundreds and hundreds, right? And all of you were scribbling. I mean, Xander, you've done GCSE probably more recently than most of the rest of us. What do you think of this question?
It seemed like very much at the upper end in terms of difficulty. I mean, just halfway through reading this...
Have you done it? Do you think you've solved it?
I think so, yeah.
Okay.
But halfway through just even reading the question, I just got bored. It's so long, and I think it said on the thing, was it 4 marks for this question?
You only get 4 marks. So you were saying, Ems, before I interrupted, sorry.
I think with something like this, and it's going to be 4 marks, you can't have someone, you can't lose interest in it. You've got to be really engaged. So I think that's the first thing. Have a straightforward question with some really great maths in. And also it's thinking about the reading level, because not everybody who is great at maths or really, strong at maths is great necessarily at the reading, and this takes a lot of comprehension to get the head round. And let's face it, reading comprehension has been a lot in the news with younger children in the last week and the publication of the SATS paper today. So, for comprehension side, it's challenging. I can see they've tried to do real life, mobile phones, televisions, but really, it's probably an example of a question, written by a mathematician trying to think about real life, but perhaps not quite with the children. And I think there was a good question a few years ago about sweets, and when somebody was sharing some sweets, and that also hit the headlines with everybody trying to solve that one when they came out of the exam room. So kind of your era maybe as well. Yeah.
Lewis?
Yeah, so I agree with you, Ems. It's a boring question, and I didn't
have you
exactly.
Done it? Have you solved
I've got
it?
an answer, and I'd be curious if you've got the same answer. But what I like about this sort of kind of question is it's challenging how well you can basically do translation between different languages. How can you take this slightly awkwardly phrased English sentence and then write it as a math sentence, i.e. an equation, and you get two equations, simultaneous equations, and you merge them together, and out the end pops two answers, two numbers, and it's kind of satisfying. You've solved a puzzle, although I really couldn't care less about the answer.
What is really interesting is that both of you have sort of said it's about translation, these questions. It's about you take what someone has set as a challenge in English and you've got to translate it into maths speak, but your maths speak. And that was the point you were making, isn't it, Ems? Can you put us out of our misery now and tell us how to do it?
Now, you've got somebody here who's the director of Enrich, and what we try to do is give hints and tips. So when I've been scribbling, I've been trying to think of the different ways that students might do this to give hints and tips. So folk at home are thinking, do you know what, that is a brilliant question. I'm not going to go to sleep tonight till I've solved it. So they can have a go. And what I would say is one of my colleagues, who was also called Chris, had a really lovely way of solving these problems when the numbers get a little bit challenging, okay? And he said, think of something that's a little bit simpler. So forget about these, adding on these numbers and it's TVs and all this. Just think, maybe you've got a £20 note and you're going to be sharing it in a simple ratio, maybe 2 to 3. How are you going to do that? So make it simple to begin with. So when folk are listening to that question and wondering, what on earth is this GCSE maths question asking me? Bring it down, make it more simple, get your head around it. And once you've had that chance to play with it on a much more simple level and you can put it into your own words a little bit more easily, then you can do what we've all been doing here, scribbling away with the simultaneous equations. So
go on
that
then.
would be my hint.
You have to put us out of our misery and tell us how to do it and what the answer is.
Just like if I was showing a £20 note and maybe one person was getting 2 parts and the person was getting 3 parts, which kind of seems unfair, but that's the way these ratio things work. Altogether, that I'd be showing it into 5 parts. What I'd be looking for then is saying, well, what's one part going to be? So I've got £20, 5 parts, then I'm looking at £4 for each part, and then I'm multiplying it up. Using that approach, and then looking at the question, I'm writing out in a similar way, and I'm using my X's and Y's with adding my 40, taking off my 100, and then I can work through my answer. At which point, I'd just like to check with my colleagues in the room. Similar way, different way? How do you guys go about it?
Yes, I wrote 2 sentences in maths. So my first sentence was x plus 40 over y plus 40 equals 15 over 22, which is the adding £40, and a ratio is basically just a fraction. And then similarly with the second sentence in maths language was x minus 100 over y minus 100 equals 8 over 15. And then you multiply it all out and you get x equals some gubbins, and then you substitute that gubbins into the other equation, and then you churn through the sort of the gears of maths, and it's like 4 or 5 lines of squibbles until, like I say, it's almost sort of elegant. The answer just plops out.
And Xander, the same way?
More or less.
It's like a countdown, this, isn't it? The same way. Show you working.
Yeah, sometimes you can kind of see tricks with this. Yeah, I've been doing an obscene amount of maths for my degree, so occasionally I sort of spot just like kind of shortcuts. One equation subtracted from the other gives like 7x minus 7y equals something, and then you can divide by 7 and get it a simpler thing in terms of just x and y rather than any factors out the front. So there are kind of shortcuts you can get with enough experience.
I'm relieved that you solved it, you lot, but I thought that was quite... It was the English that killed it rather than the maths, though, wasn't it? It's not hard maths. It's hard to turn into maths speak, I think.
And I think that shows the skill in writing questions, and that sometimes perhaps, even though folk are very well-meaning, they don't always get it quite right.
Indeed. One for you, Zander. A few weeks ago, we had a lot of feedback around us talking about a piece on microgravity and bone density in astronauts, and Paul is reacting to that, and he says, are there any other impacts on the human body of being exposed to microgravity, and will this inhibit or limit our chances of colonising other planets?
Yeah, there's quite a few difficulties that we have with microgravity. We're really not designed. I mean, we have been experiencing lots of different conditions as we've been evolving, but the Earth's gravity has been a complete constant throughout all of that. So we've really adapted to precisely the gravity that we experience on Earth. There are a few things that people find when astronauts come back from the International Space Station, for example, that they experience. There was one study in particular which was quite cool because they had a pair of twins, one of whom was an astronaut and went up there, and one of whom stayed on Earth. So that when he came back, they were able to compare between the two. And that's just one example of several studies. But the main things that you get, decreased bone density, as the question said, that decreases, I think, by about 1 or 2% per month, which is quite significant if you're up there for several months at a time. Your muscle mass goes down, obviously, because you don't have to fight gravity all the time, so you kind of atrophy. There's a particular problem with the heart because, I mean, normally here on Earth, the heart has to pump blood upwards to the head, but in space you don't have to do that. So your heart kind of atrophies over time, and then you have decreased blood pressure, and it starts to become a problem.
I was just thinking, when you're talking about all of that, the news the other day that they're training the first astronaut who has an artificial limb, and the difficulties that they were facing when they were training on that vomit comet, which trying to get their leg to bend.
Yeah, I'm sure. I mean, in pretty much any field of life, if you have a disability, that's going to be... Often people don't think about that kind of thing when they're designing the experiences people are going to have.
So in other words, yeah, it will be a problem, and we need, but it can be surmounted. We need to think about the fact that our physiology isn't necessarily adapted to these other places, and compensate, whether that's compensating with drugs, with exercise, or with other ways of keeping people fit and healthy. Yeah,
and the way that they typically try and mitigate this kind of thing is by primarily exercise. I mean, there was a great example, Tim Peake, when he was still up there, he ran a marathon, was it, or half marathon? And the way it worked is he was on a treadmill and he was kind of strapped downwards to the quote unquote floor. You've got to have impact, haven't you? You've got to load your muscles and your bones. Exactly. Otherwise they, as you say, fall apart and atrophy. And you come home with the skeleton of a 70-year-old. Yeah. I mean, when they come back to Earth, they do typically have some moderate physiotherapy that they have to go through and to be like a functioning person again once they come back.
The Naked Scientists podcast is produced in association with Spitfire, cost-effective voice, internet and IP engineering services for UK businesses. Find out how Spitfire can empower your company at spitfire.co.uk.
Music in the programme is sponsored by Epidemic Sound, perfect music for audio and video productions.
You're listening to The Naked Scientists. I'm Chris Smith, and with me are astrobiologist Lewis Dartnell, mathematician Ems Lord, materials scientist Anna Pshaisky, and astronomer Zander Byrne. And now it is that part of the programme where the teams compete to see who has one of the biggest brains and who, on the other hand, is going to go home with their academic tail between their legs, because it is quiz time. You at home, of course, can play along too. And what's interesting is that we have Team 1, who are Lewis and Ems, and Team 2, who are Zander and Anna. And that means that on each team, there is someone who has won the quiz before. So one of you is going to go home, formerly a winner, becoming a loser. So round 1 is called Imposter Syndrome. So, Team 1, Lewis and Ems. A little earlier, we heard the onset of exam season can leave many young people with the sense that they don't deserve to be excelling in their studies or worthy of their desired career path. This is the so-called Imposter Syndrome. So, can our teams spot the imposters in this round? Team 1, which of these is not a real animal? Is it A, the giant dwarf bat, B, the fried egg jellyfish, or C, the pleasing fungus beetle? What do you think, Lewis and Ems?
I think the fried egg jellyfish is a real thing, And you know what? Giant dwarf bat is kind of a contradiction in its own terms. So you think that it doesn't really exist, but also as astronomers are bad at naming things, biologists can be pretty chaotic at times as well. So I wonder if they found a dwarf bat and then found like a chuffingly big one a few years later and went, well, this is a giant dwarf. I don't know. What do you feel, Ems?
Well, I'm speaking as someone who has a bat detector. And so I'm just trying to think when I've read anything about giant dwarf bats. I mean, we've got Daubenton's here in Cambridge, down by the river, fantastic. Pipistrels at home, I watch in the evenings. I've not come across them. That doesn't mean they don't exist, possibly not in Cambridge. The second one, I was thinking, no way, but you're keen on that. So
I just thought like jellyfish kind of look like fried eggs anyway, so sure, why not?
Yeah, it kind of makes sense.
But then maybe that's the trap answer.
But what about this one that at the end, the pleasing one?
I think that's like an English translation of like the Latin phrase for what it was named at. Maybe it's sort of a slightly aesthetic fungus, and it's.
We're going to have to hurry you.
I was wondering if it was like linked to your book. You see,
are we going to go for giant dwarf bat, the fried egg jellyfish, or the pleasing fungus beetle as the imposter here?
I think giant dwarf bat. The fact that I'm a biologist, I think, should add no weight whatsoever to my gut instinct. Though.
But the fact that you are a biologist, I'm willing to go with you on this one.
It's going to be on me. Because if we lose this and you were the previous winner,
what are we going
it's going to be
for?
my fault.
Let's go for the first one.
You're going for the bat, and you get a.
Well
streaking
done.
into the lead on the Naked Scientist Big Brain of the Week quiz. Yes, you're correct. The fried egg jellyfish does what it says on the tin. It is a jellyfish. It's found in the Med. It has an orange mass on the top, which makes it look like a sunny side up egg. The pleasing fungus beetle is so called because it's a completely harmless beetle that eats fungus. The giant dwarf bat is one we made up earlier. Well done to Team 1. Ems and Lewis, you are currently in the lead with 1 point. Which of these Team 2 scientists never won a Nobel Prize in Physics? This is for Xander and Anna. Is it A, Stephen Hawking, B, Albert Einstein, or C, Niels Bohr? What do you both reckon?
I think I know this, because Albert Einstein did win a Nobel Prize. It wasn't for relativity, though, which some people are a bit confused by. I'm pretty sure Niels Bohr did, because that was around in the time when there weren't very many physicists and not very much stuff was happening. So right. I wonder if maybe Stephen Hawking was crowded out and didn't get something.
You know what? That was my gut instinct as well, was Hawking. It's also Cambridge themed, obviously, so maybe we should think that was a hint as well.
But we need a third one.
Should we go for A?
Are you going A?
Yeah, I think that's good.
Going A, and you get a...
I think so.
Yeah, well done, both of you. You did indeed correctly identify Stephen Hawking as the imposter. Despite all of his revolutionary work on black holes, Stephen Hawking never netted a Nobel Prize. Einstein, for all his work on space-time, got a prize for the photoelectric effect, and Bohr is the forefather of, or one of the mastering big brains behind quantum mechanics. That's right. Okay, so far we go into round 2, and it's level pegging with both teams 1 each. The next round is called Tech Yes or Tech No. Did you see what we did there? You spot the fake from this strange list of sublime gadgets. So, Team 1, back to Ems and Lewis. Which is the one we made up, the Tech No, in this list of strange tech? A, the smart oven with an inbuilt camera that live streams your baked goods to your mobile phone. B, the Play-Doh 3D printer. Or C, a pair of headphones that doubles up as a mask to filter the air you're breathing in. What do you both think about that? Which one is Tech Yes and which one is Tech No?
They're all like suspiciously distinct, and the sort of things that could have been invented. I think the headphones with the mask is probably a real thing. I think the Play-Doh 3D printer is probably a real thing, because I can imagine you can sort of just like squeeze it from like a syringe and extrude Play-Doh as you move it around. Sort of thing you make with like Lego.
I bet you had the
right?
mop-top hair shop when you were little, didn't you? Or you wanted one, by the sound of it.
Yeah.
Still got some envy there.
I had some Meccano. I never had Lego Technic. That was my one regret as a child. I would love for the smart oven to exist. I don't think it does.
Ems?
Well, thinking about that 3D printer, likewise, had the Play-Doh when I was younger, but also my nephew runs a factory that makes 3D printers. So the idea of Play-Doh
If only we could phone a friend with Chris
I know, that would be so fantastic.
Which are you going to go for then? Are we going for the smart oven with the speed?
You agree?
I'm going for the smart oven here,
You think that's the fake?
Yeah.
Unfortunately, you get a... No, for all your nephew's insights, the Play-Doh is the dodgy one that we made up.
You're saying that no one has made a Play-Doh 3D printer in the
Not
world?
to my knowledge.
If I were to Google
No.
that, Chris, you would stake your reputation on that?
No.
I think the answer is
I stake
yes.
James, the producer's reputation on it. All right, you get 0 for that. Yes, the smart oven is indeed real. It's made by Samsung. The headphones are also real. Dyson made that one. The Play-Doh 3D printer was an April Fool's prank, allegedly. So, we made that one up. You've got to separate the fake from the real, you two. This one, A, smartphone for left-handed people, the Air Bonsai levitating plot plant, or the selfie toaster which sears your face onto a piece of bread. Which of those is tech yes and which, Xander and Anna, is tech no?
The selfie toaster is 100% real. I'm sure people
I completely
are
agree
that
with you.
self-absorbed.
I totally agree. In fact, I really desperately want one, so I will be ordering that now.
So
Levitating bonsai
Again, I can sort of
versus a
believe that.
smartphone.
I can sort of imagine you could have a kind of magnet thing. But like, a left-handed smartphone, what would that even be conceptually? Surely it's that.
I think it's just different software, right? And I'm sure there must be a setting that you can just switch around.
Yeah, so presumably you don't need like a separate device for that.
I wouldn't think that you'd be able to a separate device wouldn't be necessary. So I reckon it's number 1 again. The smartphone
Converging on the
is...
smartphone? You're going for the
No.
smartphone?
Yeah.
Yeah,
Yay!
it is that.
Nice.
The selfie toaster, your instinct was quite right, is a real deal. The levitating plant plot, the same. There isn't such a thing as a left-handed smartphone, per se. Phones are mainly designed for right-handed people, admittedly. But some devices, as Anna suggests, let you switch your home screen interface around to cater for people who are left-handed.
Alright.
So, well done. You are currently in the lead, 2-1. So it's all on this, whether or not we go to a tiebreaker. Back to Ems and Lewis. This is called Big and Broken Noses this round. Are you ready? Why have the rugby sides, the Saracens and Sale Sharks, decided to wear their away kits in the English Premiership final on the 27th of May? Why have they decided to wear their away kits on the 27th of May? Is it A, that statistically a rugby team that wears a home kit is more likely to lose a cup final? Is it B, the scientists have found that the away kits of both sides are significantly more aerodynamic? Or is it C, because there's a clash for colourblind viewers and players? What do you think?
Nodding at C immediately, aren't we?
Yeah, I
So-
think so much in the news recently about colour blindness and more awareness.
Yeah.
So I'm kind of going for C, but yeah, the other one sounded interesting, but not quite going for those.
Yes, the more aerodynamic sounded ridiculous. There is definite advantage to playing at your home grounds, so it's definitely not A. He says, as we're saying something for a massive fail.
You going for the
C.
Yeah.
colour blindness? Yeah, it absolutely is. The Saracens have worn their black home strip against Sale, who have a maroon away kit, but there were concerns that the black on the red colour combination would make it difficult for colourblind supporters and players to differentiate between the teams. Well done. Point for you. OK, you've got to stay in the game with this one. Back to Anna and Xander. Researchers have claimed that a tall nose may be a sign of what? Is this a sign of a very high IQ, Neanderthal heritage, or a shorter than average life expectancy? What do you both think?
That's a tough
Oh
one.
gosh,
That
this
could
is
be
a
any-
bit of
IQ, I think scientists are generally kind of going away from as a concept, right?
I agree. It's a little bit eugenicsy, that one, isn't it?
A little bit, yeah. It could be Neanderthal. I mean, that the Neanderthal thing, I remember there was like a forward brow or something like that.
Or not living as long. You don't,
not
don't like,
living
you're
as
not
long.
tempted by not living so long?
Again, I think there could just be, there's just so many factors behind like lifespan, right? So presumably, I reckon it's Neanderthal one. I don't know about you.
Anna?
I'm torn between those two, you know, because maybe the shape of your nose dictates like how well, and I'm obviously speaking as an engineer here, not as a biologist, how well bugs can get up your nose, and therefore likely to limit your life.
That's a good
I'm
thought.
not sure that's the limiting factor on my lifespan is whether or not bugs can get up my nose. I reckon Neanderthal.
Anna?
Yeah, let's go with
You're going
that
on
one.
Neanderthals.
Neanderthal. Yeah, great.
Okay, so you get a point for that one, which
Very
means we
good.
don't have to go to a tiebreaker. We do have a Big Brain of the Week 2 award. We should give Xander and Anna a round of applause. Well done. You are this week's winners.
Hooray!
you very much.
Brilliant. Right, Anna, since you're there, let's stick with you. We're answering the science questions, of course, everyone at home's been sending in. Anna, we had a programme recently which was all about the right to repair, this initiative where activists are fighting back against manufacturers making gadgets that we ultimately find we cannot repair them, whether that's because we can't open them up or they're built with unique and impossible to find spare parts, the parts that you just can't replace. Are the materials in these products a big part of the reason that cheap technology breaks in the first place? Has anyone done an analysis on that? Is it a material science problem, or is it just manufacturers' avarice?
Materials will be certainly a factor, particularly if the aim is to make cheap, short-lasting products. Then the cheaper the materials, generally the weaker and the poorer their properties. But I generally think of this more as a design question. So it's about, can we design products and devices that can be easily accessed, easily opened up, and can the manufacturers develop a economy really for producing and distributing spare parts?
I must admit that I think if you ask people, have you got an old gadget from X number of years ago, they'll say yes. And then you say, have you got an old gadget that you've been able to repair from just last week? And they'll say no. So we seem to have shifted into the situation where it is impossible to repair things. But is that just because they're so damn complicated that it moves what is repairable just out of the domestic reach?
That's definitely a part of it, yeah. If you ask me to try and reconfigure the software on my phone, I absolutely would not have that knowledge. The knowledge that we have, the access that we have to the internet now means that knowledge is at our fingertips. And so the kind of pooled resources of people that do have the skills to fix stuff in big repositories online is a really kind of empowering and fantastic thing. There's a brilliant website called iFixit where people have uploaded all sorts of different ways that you can fix your devices, even complicated things that seem like you wouldn't be able to, like laptops and smartphones. The how-to guides are on there. They're designed for everyday people who aren't expert handy people to be able to access this stuff. So there is a movement, a kind of collective movement to be able to fix this stuff. That right to repair movement is taking off massively, but it's going to really rely on manufacturers as well getting on board and making it much easier for us to do so.
It's amazing what you can learn on YouTube, though, isn't it? I've learned tons on there. Let's come back to you, Lewis, and back down to earth with a little bit of a bump, because Donald wants to know, why does asparagus make your wee smell, and does the same apply to your breath?
Yes, give the biologist the wee question. It is a really, really good question. And what's going on with the asparagus is that your body is metabolizing the compounds and the food molecules in the asparagus that you eat, and creating sulfur-containing compounds. And sulfur-containing compounds often tend to be a bit pongy. So, for example, the smell of rotting eggs is another sulfurous compound. So when you eat asparagus, the molecules sort of pass through your body and you excrete them back out of your body through your pee, and so it can smell with those sulfurous compounds. But the reason you don't smell it on your breath is that, unlike alcohol, where the alcohol is evaporating back out of your mouth and you can therefore smell it in your breath, the asparagus smell has been in your bloodstream and then excreted through your bladder out in urine. So there's sort of two different systems going on there, if you like.
But if it's making wee smelly, then it must be volatile out of the urine and coming up into the room. So if it's in your bloodstream to get into your wee, why does it come
Chris,
out?
You have backed me into this corner. If you were to drink your wee, then
you smell that?
Have that wet urine in your mouth,
conundrum.
and then breathe, you would now smell asparagus wee on your breath.
I'll leave you to do the experiment. Like Ems did her maths equation, you can do the experiment next time, Lewis. Thank you very much for that. Xander, let's come to you, because the International Space Station is, we're told, going to be deorbited in 2031, so under a decade's time. And one listener's got in touch to say, well, why is that? How will that happen? And will there be a new International Space Station?
Well, the reason that they're doing it is because it's getting on a bit. It's been up there since, various parts of it have been up there since the mid-90s. And certain modules that are going in, that are part of the station, are sort of degrading over time. bits of it don't work as well as they used to. There are sometimes problems with the modules on the station. These are usually fixed by the astronauts there, but the problems are getting more frequent and more difficult and expensive to repair. The ISS itself is, by some estimates, the most expensive thing, full stop. It's estimated between $1 and $200 billion. So they're really keen to cut down on that, obviously.
We also spoke on the programme last week about the fact that this is becoming a commercial initiative. We had the report on the project involving Elon Musk's company and one other collaborator to put commercial space stations up there, starting in just 2 years' time. And the fact they're making space a commercial domain rather than an international collaborative scientific domain. They'll still do those things, but it's very much something that they think that they can get it paid for by people buying tickets, and they're so confident they've already sold tickets at $350,000 a pop.
And that's exactly why it works, is because there are always going to be people with this amount of money to throw away for a very, very short, usually, trip into space.
You're listening to The Naked Scientists. I'm Chris Smith, and with me are astrobiologist Lewis Dartnell, mathematician Ems Lord, materials scientist Anna Pshaisky, and astronomer Xander Byrne. Ems, I'm very sympathetic because this is sort of how we began the programme. John's been in touch to say, I'm hearing a lot that children need to improve their math skills, but when I take a look at my daughter's homework, I don't know where to start. He says, are we asking too much from our kids when many of them can already outperform their parents?
Really good question, John, and I'm really sorry that that's been happening to your family. I think it comes back to what our expectations are of homework. And there's so many different ways that we can support children at home with their maths or any other homework. So one way is sitting down and actually doing the homework with them. But that's not the only way. Just making sure there's a space to work, somewhere nice and quiet, checking that they've got the homework, checking that they've finished it, being there to answer any questions. They're all important too. So coming back to, what do we mean by supporting homework, I think is really important. And then the type of homework that we set. Now, in this instance, it sounds like it was something pretty challenging because, John was struggling with it. So how do we get over that problem? And perhaps it's that time to rethink what we send home as opposed to what we do in the classroom. In the classroom, we've got professionals who understand the strategies and the journey that the children are on. And some of those strategies have changed over time as well. So rather than sending home maybe new things that the children are less familiar with, using homework as an opportunity to reinforce and practice and maybe play mathematical games together so it's fun and that you can join in together can work really well. So we did a project called Solving Together where we did just that, and we did before and after, and the before sketches of doing homework were young students in their rooms by themselves doing homework. The after were sketches of family and friends sat together playing maths games, having a great time. So it can be done, it just needs that rethink of what we mean by homework.
Yeah, I did. Hear on that one. Lewis, back to you. This person says, I love this question, how far across the universe would humans have to go before we began to evolve into a different species?
Yeah, so this links into the question that Xander had earlier. And I think what's going on when your body is adapting to microgravity is actually your body is doing something really clever. It's doing its best to adapt to a new environment. And actually, by doing things like decreasing your bone density and reducing your muscle mass, it's doing a very good job of adapting to that new microgravity environment. And it only becomes a problem when you come back down to Earth and suddenly there's this gravity tugging away at you. But if you were consigned to spend the rest of your life in microgravity, maybe you become some kind of shuttle pilot between Earth and Mars and back again, you maybe don't mind that much that your body is now adapted to this microgravity environment because it suits your workplace, it suits the lifestyle you've got now. But if we're looking over a much longer time scale, over the time scale over which evolution happens, it's not really so much how far away from Earth and across the galaxy would you have to be before evolution would start kicking in. It's how long would you need to wait. And so when we do have Martians, and by that I mean boys and girls who are born on Mars from parents who've gone there as astronauts, they won't so much have evolved but their bodies will have permanently adapted to this new environment. They're likely to be quite tall and spindly because their entire skeleton body has developed and grown in 1/3 Earth gravity. And they would probably end up being sort of banished, gravitationally banished. They would never then be able to go visit their homeworld of Earth because their body is simply not capable of standing up to the gravity.
That's pause for thought, isn't it? Zonda, this is sort of similar in some respects. This person says life on Earth is carbon-based. Is carbon the only material that life forms can be made from?
It may not be the only one. People tend to disagree about this a little bit. The one that's often touted as a potential other material that could be useful for this is silicon, right? Because silicon chemically operates quite similarly to carbon in some ways. If you look on a periodic table, silicon is just below carbon, and so chemically they work quite analogously in many cases. The main reason that carbon is so good is because you can make very, very long molecules with it. You can, in theory, have a chain of carbon atoms as long as you like, and you can have a stable molecule as long as it's bounded by lots of other hydrogen atoms and things. But I think for silicon, the longest chain of silicon atoms you can have in a molecule before it starts to break apart a bit is something like 11 atoms of silicon. Beyond that, it's just not a stable molecule. So carbon is really the best for this kind of thing. It's quite difficult to imagine what life could even possibly be like using any other element.
Does this mean then, Lewis, that if we're looking for life elsewhere across the universe, that probably it will have centred on the same chemical solution that life has here on Earth?
Yeah, exactly.
The same sort of chemical recipe. As
astrobiologists, we tend to be focusing on carbon-based life or organic-based life. Firstly, we know it works. Hi. We're good examples of carbon life. But also we're very good at finding carbon-based life. We find it in places where it shouldn't be, in sort of hospital surgical theatres or in your bloodstream if you've got an infection. And for all the reasons Xana was just saying, we don't think there are viable alternatives to organic chemistry for life as we would know it. But maybe there might be alternatives to water-based life. Maybe life on another planet or moon could be ammonia-based, as it's wet stuff, as it's biosolvent, rather than water, because ammonia is also pretty good at dissolving lots of different sorts of things.
So we keep an open mind, basically.
You try to think out of the box, exactly. You don't want to be too blinkered or too focused when you're looking for something which might, by definition, be alien, be different to how we are.
Ems, let's come back to you. One of the things we've talked a lot about this week is this whole question of increasing and improving maths literacy and taking people through with some association with maths till they're 18. The one thing we haven't said is, well, what do the students think? So what do they? Have you looked at this, or what sort of feedback do you get through Enrich?
The feedback's varied. Some students, as you know, absolutely love maths and can't get enough of it. So they're very keen and enthusiastic. But there's others, let's face it, who've had bad experiences and are really not keen. So it's a mixed bag. And I think it comes back to the way that we assess the subject and their experiences perhaps when they're first going to work. I talked to somebody whose partner runs an engineering firm the other day, and they were saying when they're interviewing, the students can walk in with their GCSE maths, but actually what they get them to do is some practical work, check they can actually use a ruler and do basic skills, because although they've got their GCSE, the way it's marked, it doesn't mean you actually have all the basic skills. So employers still have to check. So I think there's that frustrating side that you've got a piece of paper, but it doesn't mean you can do the skill. Whereas if you've got a driving licence, you wouldn't have been let loose on the road unless you had those basic competencies. So it's a little bit of frustration as well.
It's almost like apprenticeship for maths then. It's about not just having the bit of paper, having been shown some techniques, it's knowing how to use them.
Exactly. It's not enough just saying, I can do some of these basic things. It's been able to demonstrate it and use it in a real life context. And we haven't quite got that right. But luckily at the moment, there's a lot of discussion about assessment. So perhaps this is a time when people are more receptive to maybe looking at different ways of doing things and hopefully move forwards.
Thanks, Ems. Anna, you were at the Royal Institution recently, weren't you, giving a talk? What was that about?
I was, yeah. I brought my talk, A Materials and Making Odyssey, to the Royal Institution. It was sort of an unofficial book launch for my book, Handmade, A Scientist's Search for Meaning Through Making, which originally came out in 2021 and the paperback has just been released. And the talk really is a sort of romp through lots of different materials. And the story of the book is how me, a relatively, I guess, theoretical scientist of materials, in that I understood the theories and formulae about how, the materials properties came about from atoms, transforming that understanding into somebody who understands how materials work in the hand, in the world of the craftspeople. So the story of the book and the story of the talk is really, what happens if you put a scientist into a blacksmith's workshop or a glass blower's lab? How can we relate what we see in the world of craft to the world of science, and vice versa? And the wonderful team at the Royal Institution made so many fantastic demos for me, including trumpets made out of chocolate, concrete, jelly, and ice. And we did lots of experiments with what happens when you try
Now
and
I'm
make
intrigued. Did they
trumpets
work?
out of different materials.
Could you
They
blow
all
them?
worked, and funnily enough, you can play them fine, and they all sound exactly the same, because what makes a trumpet sound is the air vibrating inside. It's the shape of the thing, way more than the material that it's made out of.
I can think that the chocolate trumpet would be popular for a while until it got warm and left itself all over your hands, but you might get tempted to eat the mouthpiece. The concrete one sounds like it would give
absolutely.
you very big arms trying to lift that.
Yeah, it was very heavy to lift, and the jelly one tasted delicious. Even without eating it, you could sort of taste it as you played.
Quite distracting when you're trying to make beautiful music. I've got a question
Absolutely.
to put to everybody now, which is that the world, I think, this year, I think 2023 will go down in the history books as the year of AI, won't it? It's had more headlines probably in the first 6 months of the year, almost 6 months, than the previous 6 years. And I think people all appreciate it. It seems to be reaching some kind of watershed moment. Let's start with you, Zada. Is this something that you see as directly relevant to and useful for your work?
Absolutely. I mean, astronomy as a very kind of data-driven field, we sort of have more data than we know what to do with. And machine learning in particular, that particular discipline of AI, is especially useful for picking out the interesting patterns in all of the noise, finding the useful bits of information through these swarms of data that we're getting.
And Ems, is the fact that the government appreciate we're going to need a lot of people who are very good at making, using and deploying this sort of software the reason they're so interested in maths? Because you can't write computer code if you're not at least reasonably versed in maths.
I think that's part of it. But when we're looking at these chatbots and you can put in your questions, they're actually can be incredibly valuable.
Have you tried solving any maths equations with one?
Well, what I've done is I've been putting in enriched questions, and I've put in some questions for primary age children. I've put in questions for 5-year-olds just to see what it would come out with.
What did it? I'd not thought of that. What does it do?
To begin with, I mean, it's learning as it goes along. So to begin with, I can put in a question. We've got one called eggs in baskets, and you get clues about how many eggs in each basket. You've got to work it out. It's for 5-year-olds. The answer it gave the first time was comparable to that GCSE question, lots of X's and Y's and Z's. And I put in, well, thank you. However, could you answer it in the style of a 5-year-old? And then it started using words rather than algebra. And then, because it seemed wordy, and these are 5-year-olds, I said, well, what sort of diagram might you draw? What kind of sketch? And so it's that little skill about knowing what questions to ask. So it's not just typing something in, but it's asking the question that will be helpful. So not just what's the answer, but how did you get it? What strategies might I use?
Did it reveal it's working? Did it show it's working in sort of exam speak? Because that's one of the criticisms that many individuals level at AI, that they're not explainable. They can't tell you how they got to the answer they did, unless, of course, they've gone and got it from somewhere else on the internet, seen your question that you've thrown at it before, and they've just dredged up that bit of information and parroted it.
They did come up with quite a good reasoning explanation, which wasn't the same as any that we'd got on the website already. What would concern me is the lack of visualisation at the moment, but that's an area they're working on as well. So I really value diagrams, visuals. They're great for explaining to people the thinking behind the problem. And they also, if I'm looking at something a bit more academic, I'm not getting the references at the moment where they've been looking. So do they mine our own questions? Where have they got those from? But the actual range of strategies, you can encourage it to suggest different ways. That's really valuable for a student who's stuck and just doesn't get one way. They can get another, and the first few lines can act as a hint. So if you're learning to problem solve, if you use it the right way, it can be really useful.
And in astrobiology, Lewis, useful?
Yeah, for similar reasons as Xander was saying with astrophysics, sort of churning through the data and looking for patterns. But in my sort of university post, I did a lot of lecturing and marking essays from students. And we've basically now passed a threshold where these language models are good enough that it's practically impossible to tell if a student has cheated. If they've plagiarised and they've idiotically cut and pasted a paragraph off Wikipedia, you can not only find that very easily, but prove that it is the case. If they've used a language model to create an essay, you can't prove that has happened, because you can run the same language model on the same prompt a second time and it comes up with something completely different.
You're obviously much better informed and well versed in your subject than the lecturers who were teaching Michael Crichton, who wrote Jurassic Park, because in his autobiography he says when he's at Harvard, he originally started studying English before he switched to medicine. And he said he got so dispirited and disillusioned with his teachers. In the end, he started handing in tracts of famous poets and famous writers, and they wouldn't mark them. He said, when Blake got a C, I realised English was not for me, at least at Harvard, and switched to medicine. So it was medicine and ultimately Hollywood's gain that he did that. Materials science must be a massive beneficiary of this sort of machine learning technology, Anna, for sort of doing the engineering with atoms and working out recipes for novel materials and arrangements of atoms that your subject involves.
Absolutely. In fact, I can remember during my PhD, a lot of material science is to do with, as you say, the arrangements of atoms inside materials, and machine learning can help us to predict where those atoms will sit, because there's a lot of very distinct symmetry and the sizes of atoms, for example. So these machine learning algorithms can really help us to predict, where the atoms are going to sit if you give them these different parameters, for example. And I use those during my PhD to solve, new crystalline structures that we didn't know about before.
And that is sadly all the science we have time for this week. Thank you very much to our panel, who were Lewis Dartnell, Ems Lord, Anna Poshaisky and Xander Byrne. And thanks to you at home for lending us your ears. Next time, we're going to be scratching the surface of the subject of allergies. With the rising pollen count in the Northern Hemisphere causing misery for hay fever and asthma sufferers, we're exploring what causes allergy and why they're so hard to treat. We would also be interested to hear your thoughts and experiences. If you'd like to get in touch, it's chris@thenakedscientist.com. The Naked Scientist comes to you from the University of Cambridge's Institute of Continuing Education. It's supported by Rolls-Royce. I'm Chris Smith. Thanks for listening, and until next time, goodbye.